Alright, section 2.4. This is going to be on complex numbers. Alright, normally when we had the square root of -1, we're all like, oh man, what do we do with that? And we couldn't do anything with that. Alright? Square root of -1 is not a real number, so we just left it like that. We had nothing to do with it. Now, to deal with that, what mathematicians did was say, alright, we're going to call the square root of -1 I. Alright? This is our imaginary number I. And we did this because now we can use it to work with square roots of negative numbers. Alright? So, I is equal to square root of -1. I squared is going to be square root of -1 squared, which is -1. I to the third is I squared, which is -1 times I, which is going to be -I. I to the fourth is going to be I squared, which is -1, times I squared, which is -1. This is equal to 1. And I to the fifth is going to be I to the fourth, which is 1, times I, which is just going to be I. So you see the pattern there. We get I, -1, I, 1, I. And that rotation will keep going on and on and on and on and on forever and ever. I don't know what the heck that is. Alright. So, for instance, if we have the square root of -9, well, we know the square root of -9 is really just -1 times 9, square root of -1 times 9, which is the same thing as 3 times square root of -1, which is therefore 3 times I. Alright? Again, I is used, it's for us to deal with these negative square roots. Alright, if we have a number that can't be, simplified, well, we're just going to have square root of -11 is just square root of 11 times I. Okay, proper form that we're going to have here is A plus BI. So if we're given -5 plus square root of -9, well, that's equal to -5 plus 3i. We want it in that form. Alright, and we saw that square root of -9 is 3i back here. Alright, adding and subtracting complex numbers. Well, say we have 1 plus 2i minus 4 plus 2i. That's going to be 1 plus 2i minus 4 minus 2i, which is going to be -3. Plus 2i minus 2i is 0, so it's going to be -3. Say we have 4 plus 7i times, or not times, plus 1 minus 6i. Well, that's going to be 4 plus 7i plus 1 minus 6i, which is just 4 plus 1 is 5. 7i minus 6i is just I plus I. So it's 5 plus I, which is in our form, A plus BI, 5 plus I. Alright, so you can add and subtract I terms, basically. Alright? Now, we're going to multiply complex numbers, and this is where our rules that I was talking about back here are going to come into play. Alright? So, say we have 4 minus negative 2 plus 3i. Well, we're just going to distribute that like normal. This one's not too difficult. Well, it's negative 8 plus 12i. Okay? That's our first example. Well, let's say we have 2 minus 2i times 3 minus 4i. Well, we're gonna FOIL that out. Our first term is 2 times 3 is 6. Our outer term, so that was our first term. Our outer term is 2 times negative 4i, so that's minus 8i. Our inner term is negative 2i times 3, which is minus 6i. And our last term is negative 2i times negative 4i, which is plus 8i squared. And I'm going to simplify this, and we're going to see it's 6 minus 14i plus 8i squared. Well, we know that I squared was negative 1. So this is going to be 6 minus 14i plus 8 times negative 1. So it's going to be 6 minus 8 minus 14i, which is negative 2 minus 14i, to be simplified. Alright, pretty good. So we have to just remember, I squared is the same thing as negative 1. There you go. Multiplying by conjugates. Well, in order to get rid of if we have a rational expression and we're given a complex number involving an I, we need to use a conjugate to get rid of it. Alright? So, what I mean by that is this. 1 plus I conjugate is 1 minus I. And if you see what happens here, we're going to get 1 plus I times 1 minus I. We get first, which is 1, outer, which is minus I, inner plus I. Our last term is minus I squared. Well, that is 1 minus I squared. Well, I squared is negative 1. So it's 1 minus 2. Well, it's going to be 1 minus negative 1, because I squared is negative 1, which is equal to 2. And what I mean, so the point of that was, he got rid of the i's. The i's are gone. Okay? Now we have real number. Just a real number of 2. Alright? Let me give you a couple more examples of conjugates. Alright, split right down the middle. Call these conjugates. It's going to be simple. 4 plus 3i. Conjugate's going to be 4 minus 3i. 6 plus 3i. 6 minus 3i. 8 minus 4i. 8 plus 4i. I just got a text message. Alright, you get the gist. You're keeping this term the same, and you're switching. You're taking the opposite of the I term. Okay, that's always going to be the conjugate. Alright, so you're thinking, alright, well, what's the point of the conjugate? If we're given the term 2 plus 3i over 4 minus 2i, and we want to get this in standard form, remember, this is standard form right here. A plus bi. Well, we're going to use the conjugate. The conjugate, we're going to multiply the bottom by the conjugate and the top by the conjugate. So the conjugate at the bottom is 4 plus 2i. We're going to multiply that on the top and the bottom. Just like when we did when we were just like when we were using rational expressions, and we had like, here's a little side note. Remember when we had like 4 plus the square root of 2? Well, conjugate was 4 minus square root of 2. And we did that and it canceled out. Just a side note. So, what do we get here? On the top we get 8 plus 4i plus 12i plus 6i squared over bottom, just becomes 16 minus 4i squared. Well, remember, when we multiply something with a conjugate, we're going to get rid of the i's. And then when we simplify the top, we're going to get 8 minus 6 plus 16i. Because, remember, this right here is equal to -1. That's where I got this -6 here. Alright, and on the bottom, this is really, similarly, this is -1. So on the bottom, we're going to end up with 16 plus 4. So we get 2 plus 16i over 20. And that is equal to 2/20ths plus 16i over 20, which is 1/10 plus 4/5 times I. Boom. Standard form. A plus B I. Just like we did when we were doing rationalizing denominators and we multiplied by the conjugate. You're multiplying the denominator by its conjugate. Here's where this comes into play when we're talking about quadratic expressions. Alright, normally, if I gave you x squared plus 4 equals 0, and I said solve for x, you'd say, what? Well, let's see, x squared is then equal to -4. That means x is going to be equal to plus or minus the square root of -4, which is equal to plus or minus the square root of -1 times 4, right? Which is equal to plus or minus 2 times the square root of -1, which is equal to plus or minus 2i. Square root of -1 is I. Always. Forever. Boom. Magic. Questions. 2 of them. Good luck. Happy Halloween.